Just a second. This. Yeah. So our today's topic is water. Okay. So first you tell me that if you heard the word water, if when you heard the word water, what are the properties you just quickly think? What do you think? What is a water? Anyone? Oitijjo, what is water? What do you think? Yes, Oitijjo, am I audible?
Yes, ma'am.
So what is water? What do you think?
Ma'am, it consists of two atoms of hydrogen and one atom of oxygen.
Yes, but can you tell me why water is important in our life? Water is important in our life.
Yes, ma'am.
So can you tell me why water is so important in our life? What is the reason? Without water, we cannot live, right? So why water is so important? Because it is the basic thing to live for all the living plants and animals in the world. Without water, an animal or you can say plant cannot survive. Not at all, not possible. Okay, so that's why water is so important. Okay, so now we are moving to the properties. See why water is so important. It covers 71% of Earth's surface, but its distribution is not uniform actually. Okay, so 71% of Earth's surface is covered with water, and the ocean actually, the ocean are mainly contain all the water. 97.33% ocean, 2% polar ice caps, and 1% remaining H2O. Okay, the distribution are like this. And you know that a major part, okay, a major part of all living organism is made up of water, right? Human body has 65%. Okay, human body, that means our body have 65% of water. 65%. Okay, some plants some plants have 95% of water. Okay, so you can say that it is a crucial compound for the survival of the life forms. I have already told you that that's why water is so important, and it is a solvent of great importance. So water is actually known as universal solvent. Water is known as universal solvent. Okay, so water is known as universal solvent. Most of the chemical reaction is taking place in the water. So that's why water is known as universal solvent. Okay, most of the chemical reaction is taking place in water. So that's why it is known as universal solvent. And physical properties, see, it is tasteless and odorless liquid. It freezes to ice at 273 Kelvin. That means at 0 degree centigrade. Its boiling point is 373 Kelvin. That is, you know that it is 100 degrees centigrade. The density is 1 gram per cc. And it has hydrogen bonding. Due to this, it exists as associated molecule. So we know that hydrogen are having hydrogen bonding. Let's see. See, if we consider this is the water molecule, the structure. The structure of water molecule is this. This is the structure of water molecule with 2 lone pair. Now, this hydrogen atom, will be bonded with, it will form hydrogen bond with other water molecule. This will form hydrogen bond with other water molecule. This oxygen also forming hydrogen bond with other water molecules. So in this way, they actually form an associated molecule. So because of the formation of hydrogen bond, water actually form and remain as an associated molecule. So as it is remain as an associated molecule, so that's why because of the formation of hydrogen bond, they are having various properties. Okay, so we can say that's because water has so many strong hydrogen bonds. These bonds are hydrogen bonds are strong, and its specific heat capacity is higher than any common liquid. Specific heat capacity. Specific heat capacity. So what is specific heat capacity? What is specific heat capacity? Any idea? Anyone have any idea what is specific heat capacity? Anyone have any idea what is specific heat capacity?
Amount of heat for that unit mass of the substance in 1 kg.
No, that is calorific value. Specific heat capacity is amount of heat required to rise the temperature of 1 kilogram of a substance by 1 Kelvin. Okay, so specific heat capacity, just for your information, I'm giving you the amount of heat. Okay, the amount of heat required to raise the temperature, okay, of 1 kilogram of a substance by 1 Kelvin. Okay, the amount of heat required to raise the temperature of 1 kilogram of a substance by 1 Kelvin, that is actually known as specific heat capacity. That is known as a specific heat capacity. And the specific heat capacity of water is so large. The water specific heat capacity is so large because of the formation of hydrogen bond. And as they form the hydrogen bonds, they remain as associated molecules. So that's why their specific heat capacity is quite large than the other liquid. Okay, than the other common liquid. And we know that oceans are covering 70% of our surface. oceans. Now only we have learned that. See, this not this one. Here we have learned that. See, 90, then 70. That means 70% of the Earth's surface is covered with water, and on that 70% of Earth's surface, we can say that it is covered with ocean. Okay, and see, suns are all day long. Suns are giving the energy, but the temperature of the water will not increase. In the ocean, the temperature of the water will not increase that much. It slightly increase, suppose, but it does not increase that much. The all day long, oceans are actually, the water of the oceans are absorbing energy from the sun, but their temperature is not rising on that way. Okay, so that's why all living plants and animals present on that ocean can live, because this specific heat capacity, it have a high specific heat capacity. Okay, that's why the water that aquatic animal or a plant, they can survive. Okay, I just give you one example. On the waterless, airless moon, okay, temperature ranges from 100 degree to minus 150 degree during a complete lunar day. So that means in the daytime, its temperature rises to 100 degrees centigrade, and in the night time, the temperature become minus 150 degrees centigrade. But in the Earth, it is not happened, because the presence of ocean, because the presence of water. Understood? Tell me, understood or not?
Yes, ma'am.
Okay. Now, because of the formation of hydrogen bonds, it have high heat of vaporization. So that means we have to vaporize the water. We have to give huge amount of heat, and yes, we know that the water is vaporized to 100 degrees centigrade. So because of 100 degrees centigrade, we have to apply so much of heat. Okay, hydrogen bonding is also responsible for water high surface tension and high capillarity. Water is what the capillary the capillary action of water, we know the capillary action. Okay, and the surface tension. The surface tension of water is also because of this hydrogen bonding. If we compare the water with other liquids, water always have high specific heat, thermal conductivity is high over there, surface tension, dipole moment, dielectric constant, etc. Okay, these properties allow water to play a key role in biosphere. It has a huge role in biosphere. Okay, and here one thing, that's why the order of decrease of these properties, such as, see, water has everything is very high, then H2S, then selenium hydride. H2S also can form hydrogen bond, but not like water, and selenium hydride cannot form hydrogen bond because selenium is not that much electronegative. So that's why you can say the properties of thermal conductivity or dipole moment or surface tension is decreasing in this way. Next one, see, it has high thermal conductivity. Now only I have told you, dipole moment, dielectric constant, high specific heat value. Okay, and it is an excellent solvent. All the chemical reaction which is taking place in our body, okay, it is only because of presence of water. And we know the structure of water, this one, the angle, this angle is 104.5 degree. This bond length is 97.7 picometer. Water is a polar covalent. Yes, it have dipole moment. Its crystalline form, its ice is in crystalline form. Okay, and as because it has crystalline form, it have space in them, and as because because of the presence of space, it can float on water. Okay, these are the things. Now the chemical properties. Chemical properties of water. So first, you know that as it's a universal solvent, the first is it reacts with metals to form hydrogen gas and release gas. So we will learn after in this one afterwards. First, we will learn, see, the amphoteric nature. Chemical property, in the chemical property, first thing, amphoteric nature. Amphoteric nature. Amphoteric means water has an ability to act both as acid, that means proton donor. So water can act as acid, that is proton donor. Okay, it can act as base, proton acceptor. Okay, it can act as an acid as proton donor. It can act as base, that is proton acceptor. Let's see the reaction. See, when H2O reacts with HCl, so it forms H2O plus Cl minus. Here it is act as a base. Sorry. Here this act as a base because it is acts as a proton acceptor. And if we consider this one, when H2O is reacting with ammonia, okay, it forms NH4 plus OH minus. Okay, here act as a proton donor, OH minus act as a acid because here in act as a proton donor. If we write down this reaction, see, when water is reacting with water itself, it forms H2O plus OH minus. This is self-ionization process. Water is always remain in hydronium form and in OH minus. So this is the first chemical property. The next one is redox reaction. Next one is redox reaction. Water can act as a oxidizing agent as well as reducing agent. So it can act as oxidizing agent, reducing agent. Okay. Water can act as oxidizing agent and reducing agent. Let's see the examples. So the first example, when sodium is reacting with water, sodium reacts vigorously with water and forms NaOH plus H2. Okay. So here sodium is in 0 oxidation state. Here sodium is in +1 oxidation state. So oxidations take place and water act as an reducing agent. Oxidation take place means water act as a reducing agent. Let's see one more example. When 2-fluorine is react with water, then it forms 4H plus 4F minus plus O2. So see here, this is in zero oxidation state, here is in -1. Okay, oxidation reaction. Here, these act as an,
Ma'am, why 4F1 minus?
because there is one negative charge. So reduction is here is reductions taking place. Oxidation number decreases. That means reduction. We can write this reaction like this: 4HF. The 4HF means what? Fluorine is -1, hydrogen is in +1. So reductions take place. Reductions take place means water acts as an oxidizing agent. Understood?
Yes, ma'am.
Any confusion?
No, ma'am.
Very easy this one. Now hydrolysis. The next is hydrolysis. Hydrolysis. Okay, so actually, water can hydrolyze any substance. Okay, it is the decomposition of a compound or react with water. Okay, hydrolysis is what? It is actually the decomposition of a compound on the reaction with water in which H plus gets incorporated in one part of the compound and OH minus in other. Okay, let's see. So it is a decomposition. So when carbon dioxide, see, when carbon dioxide is react with water, it forms the H2CO3. Or if I consider this NH4 plus, when react with water, it forms NH3 plus H3O plus. Okay, so actually decomposition, it is the decomposition, we can say, it is decomposition of a compound on reaction with water okay, with water in which H plus gets incorporate in one part of the compound and OH minus in the other. Okay, so this is the hydrolysis. So that means H plus will incorporate with one compound and OH minus will incorporate with other. And now next is C, hydrated salt. See, hydrolysis here, see what is given. Water hydrolyzes many ionic compounds and also help in dissociating the compounds. See, so many reactions are there. This one, this one, this one, this one, this one. So many reactions. Now, the salt in which water reacts it are called hydrated salt. And hydrated salts are actually three types. Water combined by coordinate bond, water occupying interstitial spaces, water occupying interstitial spaces, and water bonded by hydrogen. So hydrated salts, that means the salt in which water reacts are known as hydrated salt. And there are three types of hydrated salt where water combined by coordinate bond, and where water occupying interstitial species, and when where water bonded by hydrogen bond. So see, Cr OH2, this one here, water is water is forming coordinate bond with the central metal atom. Okay, here hydrated barium chloride BeCl2H2O. Here in the barium sulfate, if this is the barium sulfate, water is present here, interstitial spaces. Here water is present in the interstitial spaces, and another one is copper sulfate CuSO4 5H2O. This is hydrated salt, and here these 5 hydrogen these 5 water molecules are bonded with hydrogen bond, copper sulfate pentahydrate crystals. Clear? That's why it is blue in color.
What is a coordinate bond?
Coordinate bond is actually suppose NH4 plus, NH4 plus. Here nitrogen is bonded with 3 hydrogen, and in one is formed bond like this. That means the pair of electron is given to hydrogen. The pair of electron is giving to hydrogen. See, in ionic bond, what happened? Electron is gaining or electron is losing. In covalent bond, electron pair is sharing. In coordinate bond, the nitrogen will give its electron pair to H plus. This is the coordinate bond. You have not learned coordinate bond in the molecular bonding. Molecular bonding, you have not learned the coordinate bond.
Yes, miss.
So that is
How water is combined by coordinate bond?